Hi everyone. We are going over questions 55, 57, 59, and 61 in this video. Okay, so question 55 says, for n is equal to 1, what are the possible values of L? Well, there's several equations for these quantum numbers. N can be any integer, so 1, 2, 3, all the way up to infinity, although it typically doesn't happen. We usually stop around 6 or 7, but it could happen. So whereas L is n minus 1 down to 0, meaning that if n is equal to 2, L would equal to 1 or 0. If n is equal to 3, L would be 3 minus 1, which is 2, all the way down to 0. I'm going to stop there because that's where it was asking for. So if n is equal to 4, that means L is going to be n minus 1. So that's 4 minus 1, which is 3, all the way down to 0. So you'll have 4 different numbers here. 3, 2, 1, and then 0. The next question is asking for m sub L. This is talking about the specific orbital of it. So n is equal to some number, so on and so forth. L is n minus 1 down to 0. M sub L is positive L through 0 to negative L. So that means if, let's say, for instance, let's say n is 2. That means L would equal 1 and 0 because 2 minus 1 is 1, all the way down to 0, so 1 and 0. M sub L, there's an M sub L for every single L value. So if L is equal to 1, ML is equal to positive 1, 0, and negative 1. If L is equal to 0, like in this case, then M sub L would just be 0 because there's no positive and negative there. In the example that they've asked us, L is equal to 2. That means ML is going to be that positive 2, positive 1, 0, minus 1, minus 2. So we break this down into 2, 1, 0, 1, 2. If it was a 3, it'd be 3, 1, 3, 2, 1, 0, 1, 2, 3. We have positives and then we have negatives. If M sub L is 2, what are the possible values of L? So in order for this to be a 2, remember n is anything. L is n minus 1, and then M sub L would equal positive L to negative L. So if this is a 2, that means the L had to be a 2. It could also be a bigger number. So if I had L is equal to 3, then the ML would be positive 3, positive 2,